Welcome to this webinar. My name is Johan Terve. I'm VP Marketing at Aptilo Networks. Before we go to the agenda, let me first share a few words about Aptilo so you know the background of our company. We have been working with wireless service management and policy control solutions since 2001. Aptilo is mostly known as the world's #1 solution for carrier Wi-Fi service management with integration to the mobile core as our specialty. But our policy engine is also in action as the primary policy control function in 3GPP networks and as a AAA in Wi-Fi calling. Every day we enable connectivity for over 200 million people and even more things. And recently we have received requests from many of our 100+ operator customers to provide IT connectivity management also for cellular IoT devices. This has brought us to some groundbreaking services for IoT connectivity control, and I will talk about our new service that we launched last week at the end of this webinar. Let's now look into the agenda. I thought to keep it simple. First, we will discuss a little bit about the needs that IoT customers have and compare that to the mobile core capabilities. And then we will go over and talk about our new service, the Aptilo IoT Connectivity Control Service, IoT CCS for short, and how we can help to create innovation in the IoT connectivity space. And under the webinar screen, I hope you will find an icon for question and answers. Please use this to post your questions during the webinar. At the end, I will answer as many questions that I can, but I will of course promise to answer via email if you have particular question that is not selected. I thought to start off with this funny and, as I think you all agree, somewhat provocative picture. But it's a big element of truth in this. We all know that many mobile operators are struggling with having to deliver more for less, and that delivering new 5G services to consumers will definitely not save the day. Something else is needed. And that something, we believe, is IoT connectivity services. If we take a more serious look at this, I want to share this diagram from ITU that talks about development in penetration of different telecom services between 2001 and 2018. If we concentrate only to the broadband penetration alone, we can see that the penetration was around 7% in 2007 and 69% in 2018. That is on a global scale. I would say the penetration is 100% or more in most developing countries. I started with Aptilo in 2007, and I remember that the big thing back then that everybody was talking about was the coming 4G technology. I would say that 4G was in about the same stage as 5G is today. There is one important difference though between 4G and 5G. 4G, they had 10 times growth in subscribers to build their ROI on. And that was not only for broadband services. The penetration, as if you notice the blue line in the original picture, the penetration of cellular subscription as a whole have grown from around 57% to 107% during the same period. So of course, 5G is a natural next step, but who is going to pay for it? I don't think that we can expect consumers to pay so much more for 5G services than they do today. So IoT connectivity services to enterprises will be crucial for mobile network operators. That's for sure. What are then the features that IoT customers need that in many ways are different compared to traditional consumer mobile services? I mean, secure and seamless connectivity is just not enough. They also need to be able to decide and control exactly which devices that can connect and what they can connect to. And they also need proactive security, since the devices for the most part are not monitored by humans. They may also need a private connection for security reasons, APN, and even to be able to route some of the traffic through a private connection and some of the traffic to the quickest way out to the nearest location on the open internet. They need to control bandwidth and data usage. Many also need to apply other specific connectivity policies that are tailored to that specific use case that they have. And some may even need a global connectivity to enable a global business model. So what's in an IoT service? Let's have a look from two perspectives. The value for the customer on the y-axis and the degree of adaptation that is needed for each customer on the x-axis. If you would just take one of the consumer broadband services and repackage it as an IoT service, then I would say you end up in the lower left corner. A standard service with pretty low value for the customer. And then you can add additional features to increase the value, such as allowing customers to manage their own SIMs, provide a secure private network through enterprise APN, add to that the possibility for customers to view their own analytics, and provide more granular connectivity and security policy control. And of course, as said, international companies will need some sort of global APN connectivity. And they want some of the traffic maybe for software upgrades to go securely over APN connections, while other traffic goes to the closest route to the internet. Maybe with policies to control where this traffic can go. And of course, with the protection from firewalls. This is what we call policy-based local breakout. And then, of course, IoT customers need to have a self-service so that they can handle their connectivity policies themselves. If we then look at this matrix, we can conclude that in the lower right corner, we can call that makes no sense zone, because obviously it makes absolutely no sense to do adaptations for customers that has a low value. The more adaptations you do and the more they are dependent on getting your data and handling their own services like this, the more sticky a customer will be. So I would say in the upper right corner, we have something we can call the high profit zone. And then far to the left, we have what we can call the churn zone, where a customer easily can replace your service with somebody else that has a lower price. And it's quite obvious where we want to be. We want to be in the upper right corner, right? And the big question you have to ask yourself then is, how far can the current mobile core reach to accomplish this? Because let's realize that the mobile core of today mostly was designed for consumer services, with a handful of subscription types that relatively rarely need to be changes, and that only need a few predefined policies. But the current mobile core implementations was not made for this. In the IoT era, more or less every customer is like their own subscription type. They need their own tailored services with complex dynamic policies that are unique for each business customer, and it must be possible to make policy changes instantaneously. There's just no room to wait for the next iteration of the mobile core policy implementations. So it's a total different ball game for operators, and many operators have realized this. So basically, to answer the question, how far can the mobile core reach? Well, if you want to stay in the far left side, you can probably do that with the mobile core implementation that you have. Few predefined policies. But if you want to move into the right-hand side, you probably need a dedicated IoT mobile core. And we can see that many operators of today is doing just that. They have a separate IoT core. And the question then is that even enough? And one of our customers that came to us originally and asked us for help, they didn't think so. They didn't think that they could accomplish what they wanted, even with a dedicated IoT mobile core. And why is that? Why is a dedicated mobile core maybe not the best of ideas? Here are some of the reasons. The challenges is that the cost, of course. Just imagine the additional cost for duplicating mobile core nodes and to actually scale capacity in 2 places. And then we have the concept of APNs. That is quite all right if you have one utility company and that wants to connect 1 million metering units. Then you, of course, can set up an APN. But think about if you have thousands of business customers and each need their own APN. That will be very difficult to scale in the long run. And then we have the IoT customers that need international connectivity. For them to maintain APN connections with multiple operators is a very complex and demanding task. And as said, we were also quite surprised to hear one of our mobile operator customers to say that they simply couldn't do what they wanted with their mobile core. And they doubted that their nodes would be able to scale up enough when they had to handle granular policies for each customer. So isn't there a better way? We definitely believe there is. Please welcome up to Aptilo IoT Connectivity Control Service, Aptilo CCS for short. It's a service on Amazon AWS that works in concert with any mobile core, 4G core or future service-based 5G cores. And I would say our tagline, because you don't need another mobile core, says it all. It's only OpEx. You pay, have a pay-as-you-grow model where you pay only for the active devices connected and the data they transfer. So let's now move into the next section, how our new service can help. Let me first tell a story about how Aptilo IoT CCS was born. We were approached by mobile operator customers that came to us with a frustration and a vision. If we look at the frustration, as I said, they couldn't create the IoT connectivity services they needed. It was too complicated to deliver global IoT services. And it took too long time to launch a new customer. And I think that is a primary one. You cannot wait for months to get something done. You need to make it done instantaneously, in a matter of days. But they also had a vision. They wanted a freedom to innovate. They wanted an effective global IoT connectivity service. And they wanted to have security as a service to be able to offer that to their customers. And they wanted, of course, fast delivery and customer self-service to offload them in their daily operations. So what we came up with is Aptilo IoT CCS. It's an IoT connectivity control service that works in concert with any mobile core, as I said, and it brings the flexibility and scalability necessary for operators to innovate in the IoT era. Operators can deliver IoT services for a fraction of the cost compared to the alternatives. They can offer an instant IoT service creation, unique for each customer's individual needs, something practical impossible in the current mobile core. And as said initially, Aptilo has vast experience in policy control and to integrate with the mobile core. Our system is in action as the primary policy control in many 3GPP networks. For the IoT CCS services, our own platform handles the control plane, but we needed a partner to handle the traffic plane and the active security in the traffic plane. So we chose FortiGate's next generation firewalls from the company Fortinet to handle the data plane. And for those of you that are unfamiliar with who Fortinet is, they are among the world's top 3 providers of cybersecurity solutions. The service is delivered through Amazon Web Services for rapid scalability and the possibility for local breakout of the traffic. And Aptilo is an ABS technology partner. We also run another IoT service, connectivity service on ABS, our zero-touch Wi-Fi IoT connectivity service. And the beauty, one of the beauties with this service is that we totally remove the inconvenience of APNs. If we look at how it looks today, APNs can be quite cumbersome to deal with. Mobile operators need to set up a secure tunnel from mobile core to each customer like this. And for a customer that needs global connectivity, it's as cumbersome because they need to set up VPNs or APNs to each mobile operator out there. With Aptilo IoT CCS, mobile operators can remove the inconvenience of setting up enterprise APNs. Ordinary VPN tunnels are set up from the Aptilo IoT CCS towards each enterprise customer. The mobile operator using the Aptilo IoT CCS only have to set up one single standard APN connection to the Aptilo IoT CCS and can then handle all customers from that single connection. The Aptilo IoT CCS automatically provision a VPN tunnel to each new customer that only have to configure the tunnel from their side. For global connectivity, the mobile operator using the Aptilo IoT CCS service can connect an APN from each partner operator. This gives a very effective way to provide APNs. We will go in deeper detail soon with some of the use cases for this. And this is what we call multi-tenancy virtual APN. Without the service such as Aptilo IoT CCS, each enterprise would need to set up an individual APN with each mobile operator. Now they just need to set up one VPN tunnel and they can reach any mobile operator that the operator using Aptilo IoT CCS have partnerships with. The Aptilo virtual APN can also be used to produce multiple connections for a single IoT customer. We can set up multiple APNs to different locations, such as vehicle software upgrades to a truck vendor, for instance, or delivering data to logistics center, other transactions to the corporate headquarters. So this is the APN side. So one single customer can have different APN connections like this. All other data can go to the internet, the closest route, and all is handled through self-management. As far as we know, existing mobile core can only offer APN or internet connection, direct internet connection, so not both. So we think that this is a quite unique capability that we can offer. So what makes Aptilo IoT CCS so unique overall? Well, with Aptilo CCS, you can have specific policies per enterprise and even specific policies for each device. We will come back to that later. And we make it scalable and manageable by enabling enterprise self-service via our extensive APIs. We also provide important and security and traffic filtering features. And the policy local breakout, as we just talked about. The Aptilo IoT CCS is also in full control over the IP assignment, which means that we can apply policy-based IP configurations. Excuse me, I need some water. The real beauty with Aptilo IoT CCS is that it is a service that mobile operators just can add on to their existing mobile core. Aptilo IoT CCS takes care of all the connectivity control for IoT devices, including the traffic shaping to limit speeds, etc. The existing mobile core can remain untouched, and the packet gateways, GGSNs or PGW, only need to set up one IPsec tunnel and one GI SGI interface towards the Aptilo IoT CCS. Mobile operators OSS BSS system and can be integrated, and the self-service systems can be integrated through standard interfaces, most commonly through our flexible REST or SOAP APIs. The enterprises with their IoT devices can now connect with their individual policies, and the traffic can flow in a number of different ways. And the mobile operators can put their IoT customers in the driver's seat by offering a web-based self-management where they can set up and control their own security and connectivity policies. And there are two options for the traffic flow, really. One option is to route the traffic out to the open internet with the possibility to filter the traffic. More about this soon. Another option is to provide connectivity by securely tunneling traffic back to the enterprise through our multi-tenancy virtual APN. And as discussed a few times now, a third and truly unique capability is to provide a hybrid between the two, where selected traffic goes over the open internet with filtering, and SAM traffic goes through the multi-tenancy virtual APN. As said before, we call this policy-based local breakout. And the operator can connect partner mobile operators, of course, like this. Let's now look into the granular policies that the Aptilo IoT CCS can apply. And we can basically do policies on anything, any data that we have access to. And here are a few examples. Limiting bandwidth and data usage in a hierarchical fashion, total per enterprise, total for device group, or for each individual device. Location-based policies down to the individual cell, if we have that information, which we normally have. Time of day policies. Different types of approved services policies, such as checking if the bill is paid before they're getting access, checking if the enterprise admin have approved the device to connect. Quarantine device if, for instance, a virus is found, or if the device needs configuration after having been switched on for the first time. Our policy control is also based on a very flexible rule sets-based policy engine. So tell us what you need. If we have the information, we can always create a policy, and including using external lookups as a part of the policy evaluation. And our security features for IoT connectivities are second to none. First, we have the virtual APN we talked about, and the device traffic filtering that can filter traffic based on source, destination, IP protocol, and protocol ports. Intrusion prevention and DDoS protection is essential for large-scale services such as IoT. Antivirus through FortiGate's advanced malware protection. Deep packet inspection, DPI functions can also be enabled. And we can also detect anomalies in the traffic patterns. So let's now go in and look at a few very concrete use cases where this can come into use. First, we have a case of domestic IoT connectivity, you can say, for this imaginary forestry corporation. They obviously need a secure connectivity to their headquarters for things such as location traction of the vehicles, reporting the quantity of timber that they have cut, machine operation hours, etc., etc. But the Aptilo virtual APN can also provide secure connectivity to other places, such as upgrading of the vehicle's firmware with a truck vendor, and data exchange with the forestry machinery vendor to enable predictive maintenance. They may also want to enable internet connections for integrated tablets device in the forestry machine for the operator. And that connection is, of course, protected by FortiGate's next generation firewall. And the corporation may also want to have this protected internet connection to be controlled according to their corporate policies. Let's move on to another case for global connectivity, for moving things. In this case, I have this Fast Transport Inc., a transport company. If we first look at how they would do this typically today with existing solutions, is that they would have an APN to their mobile operator, and they have this agreement with one mobile operator. And then they would probably have the roaming charges that is quite heavy between many countries to enable connectivity between countries like this. And note that all this traffic is home routed. So there is no local breakout of the traffic anywhere. And that adds latency, etc. So the bottom line here is that you get the quite costly global roaming, and probably you only have a few predefined policies that you can play with. Let's now look at the same solution enabled by Aptilo IoT CCS. You still have one MNO agreement like this over the Aptilo IoT CCS. But then we can provide international APNs, which is a huge benefit through this service, or the mobile operator can offer this. It's not Aptilo that does that. We only offer the two to make it happen. And as the track now moves from Canada in this case down to the US, the mobile operator can do a switch to the local mobile operator with an over-the-air activation like this. And note, this have nothing to do really with IoT CCS. They can do that anyway, and it's another two that do that. But the combination between SIM localization like this and the Aptilo IoT CCS is enormous. And then it moves to Mexico, and same thing. It switched to the next mobile operator. And I must confess that it's kind of ridiculous having a track going from Canada to Brazil, but I didn't want to mess up my slide by having individual countries in the Central America. So I let this track now go the ridiculous long way to Brazil. But I think you get my meaning anyway. And now you switch to the local operator in Brazil. And note that you may have initial roaming if the policy is switched to just switch the operator after X hours or X number of bytes or something like that. So initially you may roam and then you switch the operator. And you can do policy-based local breakout through the implementations we have in the Aptilo IoT CCS. And what this gives is a global APN. You have the possibility to do granular policy and connectivity and security policies. So this is a total different service compared to the first, as you can see, and a very innovative way of selling IoT services. And I think you can guarantee that the customer that gets this and really needs it, they will be very sticky. And now let's implement this also on a stationary thing. Remember now the APNs and how we can do different policies and the SIM localization. Just imagine this company, this imaginary company, Bean and Boast, that rents out coffee machines to coffee shops all over the world. Just think about the streamlining they can do in their logistics by having one single eSIM configuration for all units in stock, instead of having to have local SIM cards for each country. And the localization happens when the machine is switched off its bootstrap to just acknowledge itself, and the operator can then switch to the local operator. And we can use the global APN, as we talked about, for software upgrades and predictive maintenance and whatnot. And I tell you, this is massive savings in logistics and less tied up capital for a company like this. And of course, we can add the policy-based breakout if needed, with lower latency and more happy users, to move the connectivity for the control of the coffee machine from the coffee shop, closer to the coffee shop. I would like to end off with tell you a little bit about our vision on unified IoT connectivity. We now have capabilities to control IoT connectivity for Wi-Fi devices and 3GPP devices. And we have our Aptilo Zero Touch Wi-Fi IoT connectivity service that runs also on AWS. And it really solves the two hurdles that you have for a mass market of Wi-Fi IoT. Namely, the secure and seamless connectivity that is needed and the onboarding of new IoT devices. And of course, if somebody comes to us and say, we want this for LoRa, we will definitely consider to add that as well. So we really see ourselves as the IoT connectivity control hub for multiple radio technologies for IoT. It's now time to summarize why Aptilo IoT CCS is such a disruptor in cellular IoT, if we concentrate now on IoT CCS. First and foremost, Aptilo IoT CCS enable business models for mobile operators that previously were considered unthinkable. And it gives them the freedom to innovate in a rapid-paced IoT era. New IoT services can be launched in days rather than months. The Aptilo IoT CCS is a service that can be deployed in concert with any mobile core, and it's 100% operational expense. And this actually means that I think this can enable virtual mobile operators that are focused on IoT services, because they can deploy good IoT services even if their network operator aren't not really prepared for it. We can provide granular and specific connectivity policy and security policies per enterprise and or device. And the enterprise customer can be placed in the driving seat by enabling a self-service through extensive APIs. This will not only reduce the cost of, this will also reduce the cost of operation for the mobile operator, because they can leave more of the operation to their customers. Aptilo IoT CCS provides security and smart traffic filtering. That's another thing. And it's the only solution, we believe, that can offer policy-based local breakout in combination with APNs. And with that, I would like to thank you for your interest and attention.